Hello, welcome once again. My dear students, hope you are in good health. Everything okay? I hope things are really quite aspiring. So now this is the second part of the video. If you are really going through the first lecture of this particular concept, now this is the application. Now the above problem clearly suggests that what is the thing? That there is a mass, particle mass 1 kg. Okay, and it has got a velocity 2 meter per second. That means it has got an initial velocity, and there is a constant force which is 2 Newton. Now what is a constant force actually? What do you mean by a constant force? So basically there are two aspects. One, F equals to f of t, which is constant. That means with respect to time, the magnitude and direction of force does not change. That means if f is constant, that means its magnitude is constant as well as its direction is also constant. So invariably a constant force indicate a constant acceleration. A constant force that will produce constant acceleration only, right? So if A is constant, then we can use all the kinematics equation like V equals to U plus AT, S equals to UT plus half AT square, and V square equals to U square plus twice AS. So the last equation is a scalar one. So let's forget this vector sign. Why it is scalar? I will explain in another video. This is the only scalar equation of this kind between the kinematics equation. So as the previous one, that S, U, A all are in the same line, in the same direction, but this question is something, here it is asks that, well, a constant force of 2 Newton acts on the particle for 1 second. So t is 1 second in a direction perpendicular to its initial velocity. That's the twist. That means now as there is a velocity and the force perpendicular acts here, so quite obviously the acceleration velocity are not in the same line. That you need to understand. So you just can't put the equation and then substitute the value. It will not work. So you need to think on that how to do it. Though all the kinematics equation can be used, but they must be in a vectorial form. So just check it out how we are doing this nice problem. So here, suppose U plus AT. So it is U and mod of U is 2 meter per second. So a constant force, that means acceleration is also constant. So let's find the acceleration. Acceleration is F by m. So it is 2 Newton divided by 1 kg. So this is AT vector, this is U, and this is AT. So this is V. Now why I have drawn this AT vector perpendicular to U? Because quite invariably, because force is perpendicular, the exerted force is perpendicular to the initial velocity vector. So the acceleration will be perpendicular to the initial velocity vector. That's why U and AT, they are perpendicular to each other. That means theta equals to 90 degree. So V means then under root of u square plus 80 mod square plus 2 u 80 cos 90. So v equals to under root of u square plus a square t square, right? Because cos 90 is 0, so it becomes 4 plus 4 into 1, because t is 1 second, so it is root 8. Root 8 means and its direction phi is tan inverse 80 mod divided by u mod. That's how it goes. So phi 1 is tan inverse 80, which is 4 into 1 by u, which is 2. Tan inverse 2 with respect to initial velocity. That's the velocity. So find the velocity at the end of 1 second. So that is the velocity at the end of 1 second. What is that? 4 root 2 meter per second with respect to initial velocity tan inverse 2. This is one part. The second part is somehow we need to find the displacement. Okay, no issue. The displacement can be done. We are using S equals to ut plus half at square. So same thing. This is our ut vector. This is half at square vector. So this is S, this is phi 2. So S is under root of ut whole square plus half a t square whole square. So which becomes ut, that means u is 2 meter per second, u is 2 meter per second. So 2 into 1, so that is 4 plus half, a is 8 by m, that is again 2 Newton by 1 kg, that is again, so it is 2 square into 1 square. So it is under root of 4 plus 2 root 6 meter, and phi 2 is tan inverse half 80 square mod by ut. It is tan inverse half into a is 2 into 1 square means 1, so half into 2 by ut, u is something 2 meter per second, right? So 2. So phi 2 is tan inverse half with respect to initial velocity. So the point remains, by this one we are able to clearly understand the basic fact that when the initial velocity vector, I mean the velocity, the displacement and the acceleration are in the same line, so you can just put the value in the basic equation and you can get the answer. But whenever the direction changes, the force direction changes, so the acceleration direction changes, then also you can apply the basic kinematics equation, because things are not varying with time, they are not functional with time, they are still, they can be used but in a proper vector addition or subtraction manner, so whatever be the requirement. So this is one of the very basic perfect example for the previous video. I hope you like it. Just like and subscribe the whole stuff. I hope that you are watching it out. You do have some basic problems, the concept level, or you do want some more thing, just send us and dispose the problem. We are just trying to solve it out as soon as it is possible. Be in good health. God bless. Thank you.